Hello and welcome to a short video. My name is Andy Schweitzer. This little video is on naming of acids. A few things that we'll cover on this particular PowerPoint or video is what is an acid, how would you recognize an acid when you see one, and how do I give a name to this acid. So I want to be able to go from the formula, and of course we'll probably recognize an acid by the formula. So from formula, I should be able to get from a formula to a name and vice versa. That's a couple of our main objectives for this particular section. As far as recognizing an acid when you see one, a couple of main things. One, an acid is what's called a hydrogen donator or a proton donator. So it starts with an H and it has some sort of anion on the back here. Now I say anion because it's usually negative. A very common example, I'll just put X down, but common examples of acids might be HCl or HNO3. These would be dissolved in water, so we put AQ. Again, this is hard to see with this marker, but it's AQ for aqueous. This is AQ for aqueous. Now, another one, HC2H3O2. This is acetic acid or vinegar. Now, it should be dissolved in water. Sometimes you might not put that down. It should be, technically. Always have an H out front. This is the H it's going to get rid of. So they're pretty easy to recognize based on this and this. Has to be out front. And there are always some exceptions. But, all right, so now, how do we give these things names, or how do we tell if one acid's different than another? Well, first of all, we have our template HX, and it's going to be in water. There are two different types of acids. One is going to be what we call an oxy acid, meaning it literally contains oxygen. And then we have our what's called non-oxy acid. So it literally just does not contain oxygen. Now, the non-oxy acid is one where the anion is simply a non-metal. We have, of the non-metals, we have nitrogen, oxygen, fluorine. We have chlorine, phosphorus, sulfur, chlorine, bromine, and iodine. Now, each one of these guys in their negative form, -3, -2, -1, when combined with an H, so these guys will fill the role of the anion here, would make an acid. And examples would be HF. This is called hydrofluoric acid. The charge will balance. This is just like an ionic compound. It's -1, +1, so that's my formula. If I chose nitrogen, it would be H, and then nitrogen would be +1 -3, so I'd have a 3 here. All right, so how do we give these things a name, this particular branch? Carbon also would be a non-metal, but it ends up covalently bonding, in this case, forming a carbon, well, 4 hydrogens would be methane. It does not have any acidic properties, so it's not usually included in that list. But the name of let's say, HCl is hydrochloric acid. And again, this is just a brief preview. You would want to follow up this video with practicing and doing a bunch of different types of problems to just become an expert at it. But let's look at this name and this formula. Again, this should have an AQ on it just to stamp it as being an acid. If it has an AQ and it has an H in front, it's an acid. It needs both of them. All right, so the hydro and the ic never change. That's the template. Put it inside this box, hydro, and then we got a root of the anion, and then ic, and then we have acid. So there we go. all I gotta do to make a different acid is simply swap out my different root. And of course, this is only for non-oxy acids. So above here, this guy's name would be hydrofluoric acid, and this would be hydronitric acid. So we have hydronitric acid. Pretty simple. Hydrofluoric, hydrobromic, hydroiodic, hydrosulfic, hydrophosphic, hydronitric. This one isn't used, and this one actually forms water. So those two are out. So there's only literally 1, 2, 3, 4, 5, 6, 7, maybe one other one, but that's it. Now, the oxy acid would follow a similar method. We have H, let's just say NO3, and HNO2. Okay, so there's two different acids here, and I know them both to be oxy acids because they both contain oxygen. Really, what we have here is this ending here is going to be a polyatomic family. I often refer to these as family acids, but they're polyatomic oxy acids. This is a polyatomic anion. So this one is using nitrate, as opposed to this one here is using nitrite. Okay, so once you recognize that it's an oxy acid and it has a family, you know what family it is, you can proceed to give it a name. This particular name doesn't start with hydro, it just simply starts with the root, okay, of the polyatomic. And then we either use ic or we use aus as an ending. If it's an 8, we would then use ic as our ending, or our suffix. If it's an ite, we would use aus. So this guy's name here would be nitric acid. And this guy's name here would be nitrous acid. Two different forms, two different chemicals, one very different than the other one. Nitric acid is very commonly used in industry. Let's do another example here. So we'll flip over to another page here, and if I were to write down, let's say, phosphoric acid. What is the formula for this? Well, first of all, I'd look at the names. Well, there's no hydro on here. So since there's no hydro, it must be using this method, okay? I'm using a family polyatomic, and I will just square this thing here so you can see that's our template. And so let's go over here. So this is a polyatomic. Every single acid starts with an H, and this guy here is either going to be phosphate or phosphite. Since it ends with ic, I'm going to have phosphate. Phosphate is PO4 minus 3. Crisscross here is a +1, and a 3 goes here. Therefore, this is phosphoric acid, H3PO4, and if we want to make it official, put it in water. There it goes, phosphoric acid. What if I were to do, let's say, another one? Let's go hydrocyanic acid. Okay. In this case, it starts with hydro. Okay, what's an acid? Let's just get this out of the way first here. Put an H out front here. What's the ending going to be? It's a non-oxy. It's got this hydro, so it's non-oxy. And cyan, that's not one we have of the non-metals. This is actually referring to Cn-, which is cyanide. So it's going to be Cn-1 + 1, put it in water, and we are done. AQ. So that's one of the examples where it's not a non-metal. It's like a chlorine or chloride or a fluoride or a bromide. In fact, it's really the only example that I could pretty much come up with that would exactly follow the single individual non-metal meaning a hydro. I think that's pretty much about it. You should be able to write a name to a formula or a formula to a name. Thank you very much.